So today we are going to discuss the next content of the data center. So let's discuss let's discuss the OTV part over here. Okay. So what is the network or like basically in the network virtualization, what is the OTV? What is the thing which is we have? So this OTV is basically it is a traditional layer 2 CCIE technology, right? And if I'm talk about the OTV challenges in the VPN, basically we have multiple challenges we can face it inside that. Okay, and what is the OTV? That is what is OTV is the stands for? The OTV stands for Overlay Transport Virtualization. Okay, so what is the overlay? What is the transport? What is the virtualization? Let's discuss. So the name of this technology describe its key characteristics, that would be overlay transport virtualization, right? So what is the overlay? So OTV provide an overlay VPN in addition to an IP network, right? So it provide the overlay VPN in addition to an IP network. It is what? It is independent in the underlying infrastructure technology and the services, right? That means we have two kind of technologies, that is underlay transfer technologies uh, and inside the layer which is we have, right, we have two kind of technologies which is it support, that is VPN and underlay infrastructure technologies, right? It does not improve any restriction on the underlying infrastructure as long as it is a capable of the transporting IP packets, right? So it is not it does not impose any restriction on the underlying technology infrastructures, right? Along with this incapable to transport IP packets. That means it just only work on the underlay VPN, and it also forward to the IP network using VPN inside the underlay technologies, right? What is the transport? So OTV
Yeah,
provide, yes.
yeah. What is underlay overlay?
See, underlay, overlay, if I'm talk about. So between the data center network, right? Let's suppose we have multiple switches over here. The Nexus series. Let's suppose this is our 5K. This is our all 5K. This is our
It is only Nexus technology,
yes. See,
and
because of
which
see
series support this?
the it also support in the other technologies as well, like your catalyst series as well, right? It is not dependent upon the particular your Nexus as well, but yes, the most of the features of this OTV is work on this Nexus series, right? So what is that underlaying? That means where your VPC and where your VDC is gonna be work. Got the point? And VPN, that means these are the things is can be connected somewhere of the internet as well, right? So overlay transport, that is this, which is directly connected in other technologies, you can say that, or in different vendors, right? So this is the overlay transport, and underlay transport is inside the VPC and VDC configuration, which is we do. Okay,
Jay, where we use this and why we use this?
that's what I'm going to discuss, right? Inside this we will discuss exactly. Okay, don't be worry about, we will on
Okay.
it. Okay, so don't be worry about, just the let's discuss the few, like what is the transport, what is the virtualization, what is the overlay first, right? So first of all we have to discuss about the basics part of that, how it works, what is that, and then we can just discuss basically what is the overlay OTV and all the things. Okay, so what is then transport? The OTV provide a layer 2 transport across a layer 3 network, right? That I have told you that it's work on a layer 2 across a layer 3 network. It can leverage all underlying capabilities to underlying transport networks such as fast convergence, load balancing, and multicast replication. That means if we need load balancing and what else? What else other, like
भाई का फोन
convergence?
आया था, मैसेज आया था कि खाली आएंगे और रात में ही चले जाएंगे, रुकेंगे नहीं।
Any doubt?
बाहर भी नहीं रुकेगी, बाहर को भी काम है, कुछ पेपर चेक करने हैं, बहुत
Sayed,
सारे।
please turn off your mic.
और कौन बचा? नहीं, नहीं कोई नहीं रुका।
Okay, so it also provide the load balancing, right? And what else? It also provide convergence because of the STP is also gonna be work on the all the kind of Cisco switches, right? And how it can provide load balancing using your L2 transport across a layer 3 network. Okay, so this is the use of transport function over here. Now, then we have virtualization. So what is that? OTV provide a virtual multi multi-access layer 2 network that support efficient transport of the unicast, multicast, and broadcast traffic. Okay, so that means the virtualization does provide this kind of efficiency of the unicast, multicast, and broadcast traffic beside of your the layer 2 network in that. Okay, this is a site can be added to an OTV overlay without a need to provisioning addition point to point connection on their sites. So basically, without checking any point to point connections between the two sites, it provide the unicast, multicast, and broadcast traffics between that. Okay, there are no virtualization circuits and then pre-down wires or the other point-to-point connections to maintain between the sites. So basically, there are no virtual circuits which is connected as we discussed. There are no virtual circuits which is connected in a two offices, or you can say the two connections, right? So it is the packet are rounded implementally for the side to side without a need to establish stateful connections between the sides. So basically, it works on a stateful connections. So what are the underlay? What is the overlay network? So let me just discuss, let me tell you exactly what is the underlay network. So underlay is a physical infrastructure above which an overlay network is built, such as your VLAN, routing, switching, Ethernet, right? So as we discussed in this scenario, so what we can do, we can create the VLAN over here, right? We have the Ethernet port or Ethernet or physical connectivity, correct? So these are the features which is we called underlay network. And what are the overlay network? Where we use the VPC, VXLAN, OTV, and VPLS. That means it also work on VPC. Yes, uh, OTV, right? This one is gonna be work inside the underlay, and this is OTV, VPLS, MPLS. These kind of protocols are gonna be work on your overlay network, VXLAN, and what else, right? If I'll tell you there's some example over here, so this is our OTV. That means this is our overlay network. This is what? This is whole network is our overlay network, and this is our underlay network, right? Where your VPC VDC is going to work, and your Ether channel, your your VLANs, right? Your physical connectivities, your switching protocols are gonna be work. That is we called underlay network. And overlay network, that means where you connected with the internet service provider, right? Where you connected with the internet service provider because of if we have the two sites, let me just mark it over here. If I will have the two sides and I just wanted to make communication in that, so what else we can do? Let's suppose here we have the site one, and inside the site we have Nexus series of Let's suppose any of the switch of the 7K. We do have the 7K series. We do have 7K and whatever the switches we have. Let's suppose. Okay. And these are what? These are connected in a each with each other would be like that. But they have also the connectivity with the router, and this routers comes inside the internet service provider. Because of this is going to attach with your what, that OSPF, your BGP are gonna be work inside that, correct? So this is connected with the different site over here. Let's suppose 5K switch are gonna be work inside the different site. Let's suppose 5K switches are there. Okay, so they are connected would be like this. Okay, so inside this, what we have, this is the same diagram, right? The OTV, where we can utilize the OTV between the edge devices of where your two sides are gonna be connected, right? That means we can configure the OTV over here, and then we can directly connect together using your OTV over here, correct? Where you're inside of this network between the OTV, what are the others technologies which is it runs? That would be your VXLAN and your MPLS, BGP, and whatever the technologies are gonna be work. So these kind of infrastructures is gonna be connected like this inside the overlay and underlay network inside of that. Got the point? That what is the underlay, what is the overlay network? Guys, say yes, no, if you have any doubt in that.
Can you repeat one more time?
I think you were speaking somewhere else.
Yes, I missed it. Actually, somebody came. Yeah, so I missed that part.
Okay.
Just go quickly. The overlay and
Yes,
underlay
yes,
here
yes.
on the diagram. Yeah.
So inside this, see where the OTV is configured, where our two devices are connected, right? The two edge devices. Because of inside of this network, our underlay network is gonna be work. Okay, and overlay, that means where you are connected with the internet service provider. Here is, let's suppose here is our internet service provider. Because of, we know that the internet service provider is going to give you this some authority to connect the two sides, that's from west side and east side inside of that. Okay, let's suppose this is the same scenario which is I have just made it. So let's suppose the site one is here and this is our site two. Okay, so underlay is this network. This is what? Let me make it correct.
So there does OTV connects to different sites.
Yes,
So what's the basic functionality like to connect to offices, to sites, to data centers?
yes,
What
yes, yes. Two sides of the
as
data centers, right? Where
as
your
a
VX,
L2
yes,
media?
as L2 or L3, L2 over L3, right? Because of we know that the L3 is gonna be work like the MPLS, BGP, and all the kind of protocols are gonna be work on the internet service provider. But if we have the VXLAN, so what does VXLAN provide? L2 over L3 configuration, right?
Yes.
So yes, see, this is not the exactly function of the VXLAN. The VXLAN is a more capable of that, right? So, but the VXLAN is, you can say that where we utilize the VXLAN, where our global, the global connectivity is there, right? In a simple terms, if I'm talk about, just like over here, this is our ISP, and inside the ISP, this is our overlay network, and this is connected with the OTV cable over here. Okay, sorry, the OTV connections.
So Jay, I have one question. When we
Mhm.
have a layer 3 connectivity, then why we would go for L2? That
See,
that that's my basic.
the L2, I'm not saying that we will go for the L2, where we can utilize the L2 inside the underlay,
Right.
right?
So OTV is a L2 or L3?
Where your STP, VLAN, right? These are gonna be work because
Mm-hmm.
of we know that what are the networks is coming inside the L2. There is our L3 and here is our L2 is gonna be work, right? Because of basic feature of this parent tree, always it works on the every Cisco switches, right? So first of all, it will check the L2, and then it will work on your L3 configuration because of whatever your packet receive, it will receive on L2 and then it will send it to the L3, right? So this is the how exactly they will exchange their informations using your L3 and L2.
So, so
Yes.
are we using OTV just to extend the L2 networks,
Yes.
like between the data
See,
centers we
for
use
yes,
V2Cs?
yes, for the same thing, right? Because of see, we know that we have the connectivity, but this is the different that is coming from the L3. But if we have the any other things which is we have to share, that would be regarding STP, VTP, or VLAN between the two sites. So what we can do, they cannot exchange their information using your L3, right? Because of this is all the kind of things is our L2. So does the router support VLAN? No. So how they can do? In this case, we have the OTV. So OTV will provide you this kind of facility L2 over L3, and then we can exchange their informations together. Got the point? We will also come over the point as well. Okay, that what is the OTV? See, it provide L2 connectivity between the remote sites, as I told you, right? So connectivity across any type of transport, like any kind of transport that you are using, it would provide the L2 connectivity between the remote sites. Now, what else? It also provide ISIS adjacency formed between the remote sites. ISIS hello encapsulate in IP multicast packet. If I'll talk about what is ISIS, so guys, please don't ask because of this is same as like OSPF. Okay. But first of all, before coming on the OSPF, it is checking all the kind of L2 neighborship, then it will goes on that. What is it provide L2 connectivity, then it will work on the ISIS, then it will remote MAC address learning on the ISIS LSPs, right? Local service provider, right? It also learns some MAC addresses which is coming via the local service providers using your ISIS. Then the different kind of tunnels is gonna be used. IP encapsulation packets are gonna be used, and then it form the point-to-point tunnel interfaces between the two sides. Like what we do between the two sides, if I have to communicate, so what we have to do, we have to create the tunnel interface. Like we have to use DMVPN, if you have remember, because of in a OTV, what we can do, you can utilize the VPN over there as well, right? Let me show you in the first over here. Where is that? See what else? It also provide the VPN additional feature of the IP network. Correct. So that means where we can utilize using your tunnel interfaces, we can use the OTV. We can configure the OTV using your tunnel interface. Then the other sites will start sending their information using tunnel as well. If our tunnel goes down, then we have this network, right? So in this is the example of the OTV, how it works and all the kind of things. Okay, don't mess it up because of the lots of things it just work on that, and the lots of remote sites are gonna be confirmed, basically forming that. Now, where we can form the OTV on the edge devices only, right? As we discussed, we can configure the OTV over on the edge devices. So that means perform OTV function a dedicated VDC on the Nexus switches. So this is the VDC is gonna be what VPC or VDC, whatever it is. A maximum of two OTV edges devices can exist at each site multi-homed homing. That means at each side they have the two OTV edge devices on that. Okay, OTV requires the transport services license. You must enable feature OTV on the VDC that will be dedicated for a such purposes. Okay, like whenever you will go to configure the VDC, then you have to enable the OTV feature over there as well, because of the VDC will provide you the encryption, coding, decoding, and all the kind of transport layer services it provide. Who will provide the VDC, right? As we discussed in the previous scenario, not the previous scenario, in the previous class, as we discussed about the VDC. So what else it can do? Creating non-default VDCs requirement advanced services licensing. That means it also create advanced services licensing over there. The edge device can be located at the aggregation layer as well as the core layer depending on the network topology of the sites. So basically we have two kind of topologies, three kinds of layer, right? Core, distribution, and what, user layer, or whatever you can say that, right? So between these two layers, what else? The core layer and the distribution layer, it works on that, right? Now let me just give you the for some more information of that. See, on a on a one side, in a one side we have two OTV, right? And this one side have these two devices, which is we called edge devices. Is it edge device, right? So both the sides have the edge device of these two, right? Either we have a Nexus series of 7000 or 9000 or 5000, whatever the series we have. It just connected using your core. Okay. So where your feature of the OTV you can configure the feature of OTV with the VDC on your edge devices only. Got the point? And then over here the internal interfaces are going to be connected would be like this, like the VLANs are going to be work, and then your V STP and all the kind of L2 interfaces are going to be connected in that. Okay, this is the same thing. So that OTV, that interface, which is we called it OTV Join Interface. Okay. So what is the OTV Join Interface? Uplink or edge devices, the join, the overlay, and the connected on the external layer three network. Because of, if we do not have any IP addresses, how they can connect, right? So we must have to configure the IP addresses, and once you configure the IP address, that interface consider itself as a layer 3 network. Because of IP address, where the IP address is configured, we can configure where your L3 is, the L3 network is going to be work. So it forwards the OTV control and the data traffic after that, right? And then it will just configure OTV join interface. We can configure the OTV join interface. Okay, so using that we can utilize the, what else we can utilize, any other routing protocol such as uh, we can configure any multicasting as well over here, right? And we can use any IGMP version in that, like IGMP group version 3. So everyone will join the particular one group, so they can exchange their information, exchange their any information using your L3 over the L2. Okay. So OTV does supports the multiple edge devices, peer sites, right? It also have the capability that it can support the multiple edge devices, peer sites in a single scenario, right? In a single OTV device, right? Then after that, we have multiple things, guys. Okay, like after that it will just share the OTV hello messages to send their information to the sites, between the sites, right? And OTV I which they will, it will exchange their some IDs in that, right? That site IDs, and then overlay adjacency, it will also share the any VLANs information and any other information of that, right? That is we call full adjacency in that. Okay, as you can see inside of that, lots of things it will share. Okay. Now, It also support multicast, unicast, and broadcast as well, right? As we discussed, like it also support the multicast, unicast, and broadcast features. So what else? Which is we can configure regarding multicast. We can configure the multicasting, IGMP group, anything, right? So if you wanted to configure or any kind of um, for the OTV, if you want to configure, so these are the configuration which is you can configure according to the unicast and multicast traffics over there. If you want to write it down, this command you can write, or you can write it down, guys. That
Yeah,
would
I've
be
gotten
great.
this OTP site identifier.
See,
Yes.
where you're getting that. Okay,
Third
this
ID.
site. So basically, this site identify is going to exchange their OTV site. That is, like, let's suppose this is the site number, right? So which is coming from the any VLAN. So you can define the particular VLAN that this interface
Yes.
is advertised into the some VLAN where your VPC is going to be work, because of without VPC and all the kind of things, how we can exchange their informations, right? So in a inner your inside the area of your of the OTV, inside of the area or of the OTV, this your sites, the two sites are gonna be work in that, like in this, right? It will share the area ID, sites ID, and all the kind of things between each other, right? Because of we know that we are connected with the two site, that is site one, and we have the some site two and somewhere. So this sites have the some site ID. If it have the some site ID, then the other site will identify that all the traffic is coming from the different site. Correct?
Okay. Yeah. Yeah.
So that is the thing. And how we can define using your port channels and the same VLAN and all the kind of things, we can define it over there. Okay, and this is the OTV interface which is we can configure, right? If you can see interface overlay one. So inside the overlay one, we are going to bind with the channel group. Okay, and then we can configure any IP on that, and then we can go for the particular port channel. Then we can bind it with the multicasting configuration over there. Okay,
Mm-hmm.
so that is what that is our L2 over L3. What is that? This is that, correct? That is L2 over L3. And this is what? Site identifier. This is the MAC address. This is the MAC address. That means this is the whole your L2 configuration. And then after that, we are going to configure the L3 configuration over the channel group, right? The port channels we are going to configure. Then after that, we are going to configure this port channel, this port channel inside the multicasting. What is that? This, right?
Yes. Yes.
So just write it down, these commands, then we will move to the next part of that, the next features. And this is very important, guys. This OTV is very important because of uh, the VXLAN, OTV, VPC, VDC, Ether channel, and your routing protocols. Whole combination will come inside the OTV, right? So this is the mix up of the Nexus feature. All the feature will come inside that. Once you are done, just let me know, guys. Done, everyone?
Yeah, done from my side. Jay, can you share this PPT?
Yeah,
Well,
definitely. I'll share it. Don't worry.
uh, thank you.
Okay, so the next things of this OTV is the OTV control plane. Because of we understand how the OTV works, how we can configure that, right? But how the control plane is going to maintain this OTV? Because of we have the two things, right? If you have remember, that is every device is going to manage the two things, that is data plane and control plane. Okay, so the data plane where your port information is there, and the control plane that your tables are there, tables, CPU, RAM, and your routing table, right? So all the kind of things is gonna be work inside of the control plane. So how exactly it works, let's discuss. So let's suppose the OTV control plane, let's suppose we have the three sites and they are just connected using the OTV, correct? They are connected using the OTV. And after that, what this? Before any MAC address can be advertised, the OTV edge device must discover each other, right? Build a neighborship relation with each other using your multicast, unicast, and broadcast. After that, the neighbor relationship build over a transport infrastructure, right? Because of that whatever the unicast multicast traffic which is it we are going to send, that's totally depend upon the broadcasting and unicasting, sorry, multicasting and unicasting, correct? Now, what is a mechanism which is it use? So the edge device join and multicast group in the transport as they were host on per interface module on the edges, right? Then OTV hellos are updated, are encapsulated in the multicast group. That means the OTV hello message, OTV hold on messages, and this kind of OTV messages are gonna be exchanged in that. Then what is the end result which is you will get? Adjacencies are maintained over the multicast group, right? Because of they just binded using the multicast group, because of the multicast enabled transport is enabled over there.
Jay, your voice is breaking.
Okay, just give me a minute. Okay, let me just make it clear. Okay, so we were discussing the OTV control plane. So the OTV control plane, let's suppose they just bind using the multicast transport over there, and the mechanism which is it use the per interface module and then it also joined a multicast group to share the any information with each other between the two sides. Once the site B will receive any kind of traffic which is coming from the any OTV different site, different OTV sites. So what it will give you the result, the adjacencies are maintained over the multicast group because of both the sites has joined the one multicast group and they are exchanging their information using the particular one group that is they joined, right? A single update release all neighbors. That means that your multicast group neighborship, right? Now, after that, what it will do? Let's suppose they just join. It suppose let's suppose they just join the unicast traffic. So in the unicast case, what will happen? They will just share the any information using unicastly. That means from this know that where I have to send the packet, this know that where I have to send the packet. That means the neighborship is already done in that. The edges, the adjacency servers between that, right? And they just encapsulated their IP addresses with each other, that this can understand what is the IP address of this and this can understand what is the IP address of this site. So they just exchange their sites IP addresses between that using your OTV unicast neighborship in that. The what is the result which is you will get, that is neighborship discovery is automated by the adjacency server. So the adjacency server will send you the particular things where your unicast transport packets is coming from, right? All signaling must be replicated for the each neighbor and the data traffic must be replicated at the between the two sites using your unicast transport group. Okay, so then after that we have the OTV data plane encapsulation as well, right? What else? So in the data plane, the 24 byte overhead of the packet of IPMTU size is gonna be exchanged in that, where your the 6 byte of the destination MAC address is going to add, 6 byte of source MAC address is going to add, the 2 bytes of the Ethernet type is going to add, like whatever the Ethernet type is it. Then it also support the 20 byte IP header and then OTV sims. The 8 byte of the OTV sims it shared. So inside the OTV sims, what are the features it just going to add? That is 802.1q header, right? That means your uh, you know um basically your port channel, your ether, your trunk ports which is you have assigned, correct? So these are the information in the OTV sim it's going to share in that. Okay, just like this. Okay, so there are some multicast transport versus unicast transport. So the packet type which is it says that is high ISIS hello unicast transport. So ISIS hello message is going to send on the both the things. It also use the unicast as well it also use multicast transport as well. And what are the length which is it use? That is these are the length. Okay, now OTV header of the user data which is it depends upon the user. Okay, so that's the thing which is it use. And if I talk about the authentication and also it is very big, right? It is very big, like you can just exchange their keys and all the kind of things. For the authentication if I'm talk about, so you must have to know about the IPsec. You must have to know about the IPsec, that is internet protocol security, right? Where your
So basically,
key,
it is completely a VPN link.
yes,
Encryption must be there and everything like we do in
Yes,
the
where
IP6
the your
tunnel.
key string are gonna be exchanged in that using your DM VPN.
So why it's so? When the L3 link is yours, like it could be MPLS or something, then why we will implement VPN over that?
See, because of between the two sides, the DM VPN always provide the end-to-end connectivity. Because of see, um, if you if I'm go with your the
So
you
suppose we
let
will
me
not take a DMVPN, we take an MPLS simply L3 link.
see
Then
let me
can we implement OTV?
let me let's suppose we are not configuring any DM VPN link using your OTV over here. So what will happen? That all the kind of traffic is gonna to exchange whatever the between the two sides are traffic is going to exchange. They will use the ISP and whatever the router and firewalls are already configured. So does these kind of devices is supported with each other? No, because of they are not capable to handle the the data centers traffics on a particular in a similar the simultaneously speed of that particularly. So that is why we use the OTV and we configure the DM VPN over IPsec over L2 over L3. That is why we use that. Otherwise, we just send the traffic using that as well. But if like suppose that if this router goes down because of the traffics would be large because of this data centers having the capability that it can manage the large traffic and it have the very good speed as well, right? But this routers does not support this kind of speed which is coming from the data centers, right? It just provide the connectivity. It is using it is what is that? This is providing just connectivity either using ISIS or OSPF or BGP or MPLS, right? But for getting after getting the connectivity after getting the IP packets between the two sides, what we can do, we can configure the OTP between the two sides. All the traffic then going to travel by the OTP link over here, that is your DM VPN traffics and all. And over this
See,
we always use the VPN, that would be IPsec VPN and all.
here my doubt is there for establishing the OTV link. We need DM VPN, is right?
See, I'm not saying that we use the DMVPN. We can use that. We have the other option as well. We can use that. But for this process, we must have to configure, the lots of things inside the DMVPN, like, uh, the spoke and hub, right? So in the DMVPN phases, we have to use the phase as well, like phase one, two, three. We have multiple phases, right? And we have the tunnel types as well, like transport mode, basically, we called it. If I'll go over there, so I have to like I have to discuss the whole DM VPN part over there. That's we don't want to. Okay, that's just
You have any
transport and
setup?
tunnel mode.
You have any setup? Configuration setup is the for establishing data center to data center.
Yes. See, for the OTV, we are going to we are going to make the connectivity directly connectivity between the two sides. Just keep remember that only, and
Yes,
that is hard. This is what this is our overlay network. This one we call it overlay network, right? Lots of things, guys. We have.
configuration between Nexus only. So apart from you telling about DM, you can also some type is available, right? I
Yes.
need data also. So I need entire fully. If you're having two data center, so we are establishing OTV, then what the thing need to be available. Even the edge router also what need to be allowed.
See,
So that part is available.
between the switches we are going to configure, right? Between the switches, because of what are the nexus are the switches, right? So always we need the layer 2 technologies for that to bind the two
Okay.
sides together.
So if you go with the latest switches, now you're telling us ISIS is right.
See, the ISIS and the MPLS, other protocols we using for the connectivity purpose between the two sides. But for the sending traffic, which is we use for the sending purpose, sending traffic purpose, which is we use, that is we are going to use the OTV over here, right? We just these are these are the ISIS OSPF. This can just only provide you the connectivity between the two sides, right? But they
Okay.
cannot handle the large data which is coming from the data center sites, right? That is why we use the OTV to share the information between that. Okay.
Slab is possible.
So sorry for that. It's not possible because of I don't have any access of this Nexus, right? Even
No, so
y-
okay, so if we get the Nexus somewhere in somewhere lab, can we do that?
for the configuration purpose, I also
Is
have
Nexus
to.
lab available, Jay?
No,
Any in any way?
no, no,
No.
no,
Like peanut and EVNG
no,
available.
not at all.
Uh,
We have available, but we must have the the image file which is we can import and then we can do configuration.
that we will not get
Yeah,
easily.
definitely. Might be I'll try
You
to
have
I'll
image
mm,
Nexus.
I don't think so, but I can download.
Okay.
I have.
I read in one Nexus book that there is a 120 days grace period and all the features are enabled for 120 days to
Yes,
evaluate
yes.
the
All
version.
the
I don't know
features
if
are
it is
available.
valid or not,
Let me show you as well. Let me show you.
but
Uh,
obviously the size would be very great. So we need a robust system also. Like that we cannot do here.
correct. Software.cisco.com. So the software is free of cost of that, right? You can define.
It should be available for evaluation for some days at least.
I don't think so that it will software download software. Okay, let me check it. I have to take the some interviews as well, and yeah, like we can just forward. We can just got it over here, right? We can go on the product and services, and like first of all we have to get login and then you can do that, right? So I'll just discuss it later, and I'll just provide you this PDF to you as well. I'm going to share it to you as well. Okay, so you can go over there and you can just read all the kind of content which is you have for the Nexus, right? So for the software, I'll once I'll forward once I'll get the particular link, so I'll just forward you the link so you can go over there and download that particular software. But we cannot perform that in our the system because of it need the higher it always needs the higher capabilities RAM and all, right? Okay, so I think that's enough for that. VPC.